Hello friends, welcome to Daring Marine YouTube channel. Today we will be discussing about the topic engine emissions. So the emission from the engine exhaust consists of sulfur oxides, nitrogen oxide, carbon monoxide, hydrocarbon, soot, smoke, etc. So these are things we also know that mainly from the emissions from the exhaust, mainly coming sulfur oxides, nitrogen oxides, carbon monoxide, hydrocarbons, soots, smoke. In air, that is for an 8.5 kilogram, for air 21% will be oxygen and 71% will be nitrogen. In a fuel, 97% will be hydrocarbon, 3% sulfur. For a lube oil, 97% hydrocarbon, 2.5% calcium and 0.5% sulfur. So for an exhaust gas, 30% will be oxygen, 75.8% will be nitrogen, 5.2% will be carbon dioxide, then 5.35% will be water, 1500 ppm will be nitrogen oxide, 600 ppm will be sulfur oxide, then 60 ppm will be carbon dioxide, 180 ppm will be HC hydrogen chloride and all. Over 99% of the emissions generated by diesel engine consist of same elements as air: nitrogen, oxygen, carbon dioxide and water. Sulfur dioxide component can be reduced effectively by choosing the right engine fuel. Emission of carbon monoxide, carbon dioxide, hydrocarbon and particulates are low due to superior thermal efficiency of diesel process. Minimizing the NOx, SOx and CO2 emissions is very important to protect the marine environment. NOx formation in diesel engine is primarily caused by locally high combustion temperature in the combustion space. For SOx, these are oxides of sulfur, depending mainly on the sulfur content in fuel. Its effect is sulfur get oxidized to form SO2 and SO3 in the ratio 15:1. Sulfur oxides emitted from the engine combine with rain in the atmosphere to form sulfuric acid, that is acid rain. The SOx limits, that is 4.5% when operating anywhere in the world, it's an old thing. Then 1.5 when operating in new SOx emission control area. These are old, now 0.5%. Then remedy and control: low level sulfur fuel to be used, which however increase the cost. So we have to remove sulfur from the fuel. So wash the exhaust gas in the scrubber tubber and then we have to neutralize it. And we have to use high alkaline cylinder lube oil to neutralize the sulfur in the fuel, thereby reducing sulfur corrosion and slightly reducing the emission. So sulfur can be measured by different methods: infrared, ultraviolet or electrochemical sensors. Then NOx, these are oxides of nitrogen which cause smoke formation and local ozone concentration. Nitrogen is present in the fuel as well as in the excess air provided for the combustion. During combustion, nitrogen combines with oxygen to form nitrogen oxide. This nitrogen oxide then gets converted into nitrogen dioxide and nitrogen oxide in the form with the ratio of 5:1. Nitrous oxide destroys the stratospheric zone. So NOx limit for new or converter engines by the year 2000 operating below 130 rpm, limit is 17 gram per kilowatt hour. Remedy and control: basically if you use the cylinder temperature less, NOx will be produced. Modern day engines have large bore and slow speed, both resulting in high gas and cylinder temperature. Therefore large quantities of NOx are produced. So method use are: later injection during the combustion process is carried out. This reduces the cylinder temperature, but peak pressure and specific fuel consumption increase. Using fuel water emission: water present in fuel absorbs some of the heat generated during combustion. That means 1% water addition reduces NOx by 1%, but the specific fuel consumption increased by 0.3% as penalty. Fuel injector nozzle adaptation as in the slide value design: water injection or humidification. Exhaust gas recirculation: where exhaust gas is recirculated back to scavenge side. This reduces the oxygen content of the air supplied to the engine, thereby reducing the amount of NOx produced, increasing the scavenge pressure and combustion ratio. This gives a larger quantity of air to the combustion cylinder, thereby reducing the cylinder temperature and diluting the NOx already formed. Although this method improves specific fuel consumption slightly, it hardly reduces the NOx emission. Selective catalytic reduction (SCR). That means exhaust gas is mixed with ammonia and a selective catalyst at a temperature of 290 to 450 degrees Celsius. The NOx is converted to nitrogen water. NOx reduces to 130 rpm, that is 90% reduction, making it most cost efficient method. But the specific fuel consumption increases by 2 to 3%, and SCR plant, that means selective catalytic reduction plant, is a bulky one. So reduction agent here is urea, which is harmless substance used in the agricultural sector. The urea solution is injected into the exhaust gas directly after the turbocharger. Urea decays immediately into ammonia and carbon monoxide. The mixture is passed through the catalyst where NOx is converted into nitrogen water. How we will measure means it is done by chemical luminescence method where NOx is converted to NO and then measured by portable electrochemical sensor used. Carbon monoxide. The exhaust emission contain large quantities of carbon monoxide because of the excess oxygen supplied into combustion air. Increasing the normal operating level indicates poor atomization of fuel by fuel injection. Hydrocarbon. These are efficient and correct combustion will allow a very small percentage of hydrocarbon in the emission. Hydrocarbon are basically unburned fuel particles. Particle emission. The particles and soot in the exhaust emission come from partially burnt lube oil, ash in the fuel or lube oil which includes unconsumed calcium additives and the deposits peeling off from the cylinder or the exhaust system. Soot. Soot is the agglomeration of minute partially burnt fuel particles. It is formed during combustion by very poor burning of fuel without a flame. This type of burning, called pyrolysis, can burn only later fractions of fuel particles, leaving the partially burned remainder as soot. Soot increases with slow burning as asphaltene fuels. Burning of fuel impinged on the relatively polar lane surface and with large fuel droplets. Soot is an environment pollutant as well. It faults exhaust uptake and increases the exhaust boiler back pressure, sparking or even soot fires. Smoke and opacity. It is a degree of blackening of white filter paper or the amount of light reduction when light is passed through the exhaust fluid. So measurement mainly is Bosch smoke scale, mainly 0 to 10%. The other method to measure the smoke and opacity is Beshark smoke scale, Hartridge smoke scale, Ringelmann number. These are the methods to measure the smoke and opacity. Thank you.